Hello, this is Mr. Wynn, and today's video will be about completing the square. So the square root property is great for solving quadratics. You can use it when there is only one letter in the equation stuck with the squared exponent. So here's an example, x squared equals 100. I have one letter x, and it's squared. All you have to do is square root both sides. Well, the left side just lose the exponent, and the right side, make sure you have a plus or minus, positive or negative, and the square root of 100 is 10. Alright, so if I have letter squared on the left or something with the letter squared on the left, I can square root it and then do the plus or minus of whatever the right thing is. So solve this by using the square root property. Now there's more than one letter in the equation, so I just want one letter. So I'm going to try factor the left side. If y'all remember, we have the x method. We're trying to find two numbers that multiply to 9 but add to positive 6. So 9 is 1 times 9, but that can't make 6. It's also 3 times 3, which could make 6. So I'm going to do positive 3 are my factors. Alright, because positive 3 plus 3 is 6, 3 times 3 is 9. So this left side turns into x plus 3, x plus 3. That equals 36. Now you notice that the left side is the exact same, x plus 3. So I could write x plus 3 squared, so that means the same thing twice, equals 36. Now I can use the square root property. The square root property means just square root both sides. Left side just loses the square, this is just x plus 3. Right is a positive or negative, and square root of 36 is 6. Now to solve this, to solve for x, I'm going to have to subtract 3 both sides. Now, this negative does not go with 6, that's a positive negative 6. This is really x equals negative 3 plus or minus 6. That plus or minus means there's two cases. So my first case will be negative 3 plus 6. My second case will be negative 3 minus 6. So negative 3 plus 6 is positive 3 is an answer. Negative 3 minus 6 is negative 9 is an answer. Those are my two solutions. So notice I turned the left side into a single letter stuck with this squared, x plus 3 squared, equals number. I squared both sides, did the square root property. So it's x plus 3 equals plus or minus 6. Got x by itself by moving the number in front, and then doing the two cases, the positive case and the negative case. So we don't always get nice numbers like that where we can turn the left side into a perfect square. So there's a technique called completing the square. So all quadratic equations can be solved using the square root property by manipulating or forcing the equation till one side is perfect. That method is called completing the square. So look at x squared plus 16x equals 9. I want to turn this left side into something perfect, but I don't know what. So there's the missing number right here, that blue box. I call that the magic number. We have to figure out what that magic number is to turn the left side into x plus or minus something squared. And they figured out that number was 64, because without a 64 there, the left side turns into this thing. And now we can square both sides. For them to find that magic number, they did 16 divided by 2 squared. So 16 was the number next to x. That was our b term. Divide by 2 makes it 8. 8 squared is 64. And what you do to one side, you do both sides. So they add 64 to both sides, because you can't just have 164 pop for no reason, because they really cancel out if I subtract them. Alright, so let's do our own problem. Solve this by completing the square. Now before I do that, let me actually solve it another way so y'all can see. That, there's no GCF, but I could factor it by doing the x method. So I'm trying to figure out two numbers that multiply to negative 11, but add to positive 10. So 11 is just 1 times 11, it's nothing else. Can I make 10? Yeah, I can. That could be positive 11 and minus 1. So 11 minus 1 is positive 10. Positive 11 times negative 1 is negative 11. So here I would get my factors, which is x plus 11, x minus 11, that equals 0. And remember the 0 product property, set each of those equals 0. So a quick review real fast. This is a minus 1, sorry. So both those equal 0 and solve them. So I subtract 11 both sides and I add 1 to both sides. They're my two solutions, my two x-intercepts, my two roots, and my two zeros. Alright, now they want me to solve by completing the square. So completing the square says get the left side empty. Get the x's on the left and the other numbers on the other side. So here, I need to move that 11. So I add it to the other side. Here's my brand new equation. Pause 11. So I'm missing something right here to make a perfect square. That's a magic number. To find the magic number, you do b divided by 2. Then you square that. So 10 is our b. 10 divided by 2 is 5. 5 squared is 25. So now I have x squared plus 10x. I'm putting a 25 right here. That equals 11 plus 25. Because what I do to one side, I do both sides. Well, this left side now turns into a perfect square. That is really x plus 5 times x plus 5. And that equals 36. Or if you want to, they're the same thing. You can go straight to the step. X plus 5 squared equals 36. Now I have a single letter on the left stuck with a squared. I'm allowed to do the the square root property. I square root both sides. This is left side turns this x plus 5. It lost the square power. This equals plus or minus 6. Now solve for x by subtracting 5 both sides. Now remember, that does not go the 6 because that's the plus or minus 6. That's two cases. It goes in front. Now I'm going to do the two cases. The first case will be the negative 5 plus 6. And the second case will be the negative 5 minus 6. Well, if I calculate that, negative 5 plus 6 is 1. Negative 5 minus 6 is negative 11. Those are the exact same two answers from the other side. X equals 1, x equals negative 11. So you can always do completing the square. That always sets up the square root property. Now, one more time, solve by completing the square. Now, if you have a number next to x squared, so you have an a, so a isn't 1 like this, you have to get rid of it by dividing by it. So you have to divide the whole thing, both sides by 2. So this is really x squared plus 8x plus 22 equals 0. Now again, completing the square, I need to get the x's by themselves on the left, so I need to move this 22 over by subtracting it. So I have x squared plus 8x equals negative 22. Now I gotta find this magic number. I gotta figure out what this thing is. So to find the magic number again, I divide b by 2 and square it. So 8 divided by 2 is 4. 4 squared is 16. That missing number is the positive 16. And what you do to one side, you do to the other side. So I add 16 to both sides. So this left side is a perfect square. I can turn it to x plus 4. And that's going to be negative 6. Now I have a square on the left, perfect square on the left. Just the letter x stuck in squared, a number. I can use square root property by square rooting both sides. Square both sides. The left side is turned to this. The right side is plus or minus square root of negative 6. Well, square root of negative is I. And 6 stays there. Now solve for x, get x by itself. I'm going to subtract 4. That goes in front. So my answer here is x equals negative 4 plus or minus I square root 6. And that's good enough. If you want to separate this into two cases, you can, but you're not going to be able to do anything with it because it has I. So you're going to do two cases. First one's negative 4 plus I square root 6. The other one is negative 4 minus I square root of 6. Those are my two solutions. They're imaginary. Alright, I'm going to end with this. Here's the practice problem. Solve it by completing the square. You should get two nice answers, 4 and 6. Those are the intercepts, the solutions, roots, zeros. And if you can do that, you should be fine for the quiz. Alright, this is Mr. Nguyen. Thanks for watching. See you in class.